Okay, this is concept number 7, which is your Keystone square root problems. So and these can be tough to begin, but the more you get doing them, they're easier because it's the same process every time, just different values that you're dealing with. So in the first one, you were given the square root of 40 times x. Okay, and you were told that that equals the 10 times square root of 2. So they're giving you the answer to this. Okay, so I already know what this simplifies down to completely. What I don't know is what x value is actually in here to make this true. I don't know what this value of x is. It's going to make this simplify down to a 10 times the square root of 2. To start these out, you want to simplify what you were given. Okay? So this square root of 40, we need to simplify first using our factor tree. So 2 times 20, 2 times 10, 2 times 5. Okay? Do your pairings just like normal. So these pairs of 2 turn into a single 2. And then you're left with this 2 times 5 afterwards, because those don't pair up, which turn back into a 10 inside of your square root. So really, what we have right now is we know that this is 2 times the square root of 10 right now. Okay? So we need to figure out what value for x then is going to turn that into 10 times the square root of 2. Okay? So now you have to kind of start comparing. Okay? This 10 we know breaks down into a 2 and a 5 that did not pair up. We have a 2 on the outside right now, and that needs to become a 10 on the outside. So the only way for that to happen is if this 2 got multiplied by a 5 somehow. Okay? Which means if my outside number is getting changed, that means there had to have been a pair of these numbers on the inside that allowed me to bring it to the outside as one of them. So I know that this breaks down into a 2 and a 5. Because this was multiplied by 5, there had to be a pair of 5s on the inside. Well, I already have a single 5 here, which means this x had to be my other 5. Okay. So now underneath the square root, I have the 2 times 5 for the 10. I have the extra 5 from this changing, which means that that missing piece had to be our 5. So let's look at the second one. This one's multiple choice, which a lot of times these questions are when you see them on the Keystones. A lot of times these are multiple choice questions, which can truly benefit you in the long run. It'll make these problems a little bit easier because you can plug these numbers back in to try them. So if we're given the square root of 30x, and we're told that it has to equal 3 times the square root of 10 whenever we're all done. So if you break down this 30 first. So again, you're always breaking this number down first. So I have 2 times 15 and 3 times 5. Okay? None of these pair up. These are my prime numbers. I have to figure out if I start breaking these numbers down. So if I put in a 3 for x and I break it apart, will it pair up with any of the prime numbers that I already have? Okay? Now in this case, answer choice A is the correct answer. It's 3. 3 is a prime number, so if I put that in for x, I don't have to break it down at all. That is my prime number, which would pair up with the other 3 that I already had. When I pair that up, that allows those to come to the outside. All right, that gives me a pair of 3, so I get a single 3 on the outside. I have a 2 and a 5 left over, which is my square root of 10, which matches what I was given originally. Another choice you have is you could plug in these answer choices for x and see which ones give you the same values. Okay, so you can plug in the square root of 3 or 3 times the square root of 10 into your calculator to get that decimal answer. Then plug in this 3 for x, type that into your calculator. Plug in the 6 for the x, plug that into your calculator until you find one that matches what you were given originally. Okay, so it's always an option that you have. Now in this example here, we want to know what value of x will make this a true statement. So 5 times the square root of 39x equals 35 times the square root of 39. Okay, so I need to again figure out what value of x is going to make all of this true. Best thing you can do with these, you're going to have to compare 2 different values. You're going to have to compare your outside numbers, and then you're going to have to compare your inside numbers. This 5 on the outside changed to a 35 on the outside. Okay? The only way for that to happen was that this 5 got multiplied by 7. Now, keep in mind that if this 7 somehow appeared on the outside of my square root, that meant it had to have started out as a pair of 7s from the inside. Okay, so I really had a pair of 7s on the inside because of that outside number changing. Okay, so I know I had a 7 times 7 in here, which would give me a 49. But then you also have to check your inside numbers. In this case, this 39 did not change. Okay, so because that 39 did not change, you don't have any other work to do. So your final answer is just going to be 49 from that pair of 7s. Okay, and that was simply because this 5 got multiplied by 7 to become a 35. Okay, and again, if you have a number that is moving to the outside of a square root, that meant it had to be a pair of them on the inside. So I had a pair of 7s on the inside. What value of x will make this a true statement? So I have 2 times the square root of 42 equals 14 times the square root of 6. So again, I need to compare my outside numbers, and then I'll compare my inside numbers. So on the outside, this 2 changed to a 14, which means it had to have gotten multiplied by 7. If there was a 7 that appeared on the outside, so if I was able to bring out a single 7 to the outside of my square root, that meant it had to be a pair of 7s on the inside. Okay, so this definitely had to be a pair of 7s in here. However, this 42, if I break that apart, gives me 2 times 21 and 3 times 7. So this 2 times 3 is what gives you your 6. This 7 is one of my pair. So the x is my other 7 that showed up. So there was a pair of 7s that had to be put inside of here. However, you can't just assume that it's a 49 because this 42 breaks apart and I have a single 7 there. So this 7 was my other piece of it. So I only need one more 7 to make this happen. So my answer is just 7. Okay, which value of x will make this expression need simplified? Okay. If they want it to be simplified, that means you have to pair up numbers. Okay, so if a square root needs simplified, it needs the factor tree to have pairs in them. So if I start breaking down what I have, 87 breaks into 3 times 29. Okay, that's all that I can break this down into. Those are both prime numbers. So if this is going to be simplified, whatever value I put in for x, when I break it down, I have to be able to pair it up with either this 3 or this 29. So if I put in a 10, 10 breaks down into 2 and 5. Well, neither of those values are going to pair up with these values, so it can't be 10. If I put in a 13, 13 breaks down into 13 and 1. It's a prime number. Again, I'm not going to have any pairs to combine together. If I try 21, 21 breaks into 3 and 7. My 3's will be able to pair up, which will allow this to simplify, because remember, if they make a pair, that means I can move them to the outside of the square root, which is what you're doing when you're simplifying. So because I was able to find a pair, that means that C is your final answer. Same thing here. If I have 85x and I want that to be simplified, 85 breaks down into 5 times 17. So now I check all of my answer choices. If I put in a 3 for x, 3 is already prime. I can't even break it down. And 3 doesn't pair up with the 5 or the 17. Okay? 59 is a prime number. It does not break down, and it does not pair up with the 2 values that I already had. 94 breaks apart into 2 times 47. Again, neither one of these pair up with the values that I need them to pair up with. So then 235 breaks apart into 5 and 47. So when I break that apart, it allows my 5's to pair up because they match. So the answer has to be D. Same thing here, 182x. Break that apart, you get 2 times 91. So you need to figure out what number could you put in for x that when you break it apart, either has a prime number of a 2 or a prime number of a 91 to pair up. The only one that happens with is answer choice C, because the 2's pair up. Okay, so it had to be 14 that was your x value. Now, in this last one, we want them to not simplify, which means I don't want pairs. Okay, so I'm looking for the complete opposite of what we've been doing. When I plug in my value for x, I don't want there to be any pairs in this case because I don't want it to simplify. So 57 breaks apart into 3 times 19. So if I put in a 3 for x, that's automatically going to pair up with 3 that I already had. So it cannot be answer choice A. If I plug in a 19, 19 is prime, but it pairs up with the 19 that I already had. So again, cannot be my answer choice here because I do not want these to simplify. Then if I try the 20, well, 20 breaks down into 2 times 10, which breaks down into 2 times 5. So my prime numbers are 2, 2, and 5. Now, that does not give me any pairs from my original. So it's not going to simplify with the original value because there are no pairs with what I originally had. So it has to be answer choice C. Again, this is the Keystone square root problems, which is your concept number 7. Try these. They're tough. The more that you practice them, the easier that they get. You just really have to work hard at these to fully understand them.